Okay, now we're going to do section 4.2, but we're going to skip the first part of section 4.2 and not do Rolle's theorem. We're just going to focus on mean value theorem, okay? Mean value theorem says if your function is continuous and differentiable. So continuous means no holes, no gaps, no vertical asymptotes, right? So we have to make sure that our function is continuous. We also have to make sure that our function is differentiable, meaning no sharp turns, no points of discontinuity, so holes, gaps, vertical asymptotes, and no vertical tangents. As long as those two things happen, your function is continuous and differentiable on a certain interval, then there must be a number where the derivative, the instantaneous rate of change, is the same as the slope between your two endpoints, your average rate of change, right? And that should kind of make sense. Think about driving. If I tell you that my average speed was 65 miles per hour, well, didn't I have to then at least be going 65 miles per hour at one point in that time interval? I might not have been going 65 the whole entire time, but in order for me to get an average speed of 65, my instantaneous speed had to have been 65 at one point. And that's kind of what mean value theorem is. As long as you know that your function is continuous and differentiable, your derivative, your instantaneous rate of change, should be the same as your average rate of change, or your slope between the two endpoints, right? So if I have this picture, and I know the slope between my two endpoints, let's say, is 2, well then at some point along my function, the slope of my tangent line, my instantaneous rate of change, should also be 2 as well, right? That kind of makes sense? So let's apply the mean value theorem to a couple different problems. Let's do example number 3 here. In example number 3, I have a typo there. It's supposed to say f of x, so add a little f in there. Given f of x is 5 minus 4 over x, find all the values of c in the open interval from 1 to 4 that satisfy the mean value theorem. So I want to find all the places in the interval from 1 to 4 that satisfy the mean value theorem. Well, there's two things that have to happen in mean value theorem. Number 1, remember that your function has to be continuous and differentiable. Number 2, your instantaneous rate of change, your derivative, has to be the same as your average rate of change, the slope between your two endpoints. So let's kind of use those ideas. So I have this function, and I don't know about you, instead of writing it as 4 over x, I'm going to write it as 4 times x to the negative 1 and bring that negative 1 forward. The first thing that I need for mean value theorem is that my function has to be continuous and differentiable. When I look at this function really carefully, I don't know about you, but I noticed a red flag here, right? I have a denominator that's going to cause my function to be undefined if that denominator is ever equal to 0. And so it looks like here I have a vertical asymptote at x equals 0, right? And so my function would not be continuous or differentiable at 0. But the problem says my interval is only focused from 1 to 4. So I don't necessarily have to worry about anything outside of that interval. And since my vertical asymptote is at 0 and it's outside of my interval, then I can still say that my function is still continuous and differentiable on the interval that we're talking about. So we're still okay on this problem to use mean value theorem. If I had changed that interval and said, hey, do mean value theorem from negative 4 to 4, well, because I have a vertical asymptote at 0, I can't guarantee mean value theorem would work, so I wouldn't be able to do this problem. But since this interval is 1 to 4 and my vertical asymptote is outside, then I can still say that number 1 of mean value theorem still applies. I know that my function is continuous and differentiable on that interval because there's no other issues in my domain except for 0. So the second thing that needs to happen for mean value theorem is that my instantaneous rate of change, my derivative, should be the same as my average rate of change, the slope between my two endpoints. So off to the side, let's go ahead and do those two pieces and make sure that those two pieces are equal, because that's what mean value theorem says is supposed to happen. So I need to find the slope between my two endpoints. Well, I know that my one endpoint was over here at 1, my other endpoint was over at 4, because that was the interval that they gave me. And so I can start off with 2 points. The problem is I only have the x value of each of those points, not the y value. And so if I know that x is 1, how are we going to find the y value that corresponds with it? Well, you should be able to take that 1 and plug it into your original function to get that y value. When I plugged in 1, I ended up getting 1 as my y value as well. I need you to do the same thing for 4. When x is 4, what would the y value be in my original function? So that way I have 2 full complete points and I can find the slope between these 2 points. I ended up getting a point at 1, 1 and 4, 4. And now that I have those 2 points, I should be able to find the slope between those 2 points, the slope of my 2 endpoints, right? My average rate of change. y2 minus y1 over x2 minus x1. I ended up getting a slope then of 1. That means the slope between my 2 endpoints is 1. My average rate of change is 1. If my average rate of change is 1, then my instantaneous rate of change should also be 1 at some point in that interval. My derivative should be 1 at some point in that interval, right? And so now let's figure out that second piece and figure out what my derivative is. So I need you to take your f of x and I need you to find the derivative of that function. I ended up getting 4 over x squared. Making my exponents positive, I ended up getting 4 over x squared. So mean value theorem states that if your function is continuous and differentiable on the interval, which it is, then the instantaneous rate of change, your derivative, should be the same as your average rate of change, your slope between your 2 endpoints. So I should be able to set up an equation that says my derivative, my 4 over x squared, should be equal to my average rate of change, my slope between my 2 endpoints, of 1. I ended up putting that 1 over 1 so that I had 2 fractions equal to each other, and then I can solve, one of the methods is by cross multiplying. I can cross multiply, and I ended up getting x squared equals 4, and then I can solve for x. Now be careful, you should end up getting x equals plus or minus 2. What that's saying is that at x equals 2 and x equals negative 2, the average rate of change is the same as my instantaneous rate of change. Okay? Now, because my interval was between 1 and 4, I don't really need to focus on the negative 2 per se. I only need to find the number in my interval where it satisfies the mean value theorem. And so my final answer really is just going to be x equals positive 2. Or c equals positive 2. Some books call it c, some books call it x. So I know that there is a value in between 1 and 4 where my average rate of change is the same as my instantaneous rate of change. I've used mean value theorem to find that number. It happens to be x equals 2. Okay? Make sure you can show me all of those different pieces. Make sure you can show me that it's continuous and differentiable, number 1. And make sure, number 2, you can show me all the pieces that say that my instantaneous